Hello everyone, welcome to the online learning series. So in the previous session we had discussed about the speed and velocity. Along with speed and velocity we also discussed the average velocity, instantaneous velocity. Today in this session we are going to discuss the graphical interpretation of average velocity and instantaneous velocity using a position time graph. So what is a position time graph? See, time is an independent variable. Position is a dependent variable. That is, as time advances, the position of the body is going to change. So, in position time graph, we are going to plot the position in the y-axis and time in the x-axis. Now, first I am going to take, that is, in the first case, I am going to consider a uniform motion. As we have already studied what is uniform motion. It is a motion of the body in which the body travels equal distance in equal intervals of time. So, considering a uniform motion, I am going to get a straight line. So, this is what the position time graph I have got for a uniform motion. Next, I am going to extend this line and make a x-intercept. Let me consider this angle as theta. So, this angle, which is the angle between this straight graph and the x-axis, is taken as theta. Next, I am going to mark 2 points on the straight line. So, this is point A and this is point B. So, this A corresponds to time T1 and B corresponds to the time T2. So, the body is at position A when the time is T1 and it is at the position B at time T2. I am going to join these lines. I will draw a perpendicular here and name this as C. So, if this angle is theta, this angle also becomes theta because they are corresponding angles. So, if I draw a line from this A, this line becomes x1, that is the position of A, and next this becomes x2. Next, let us calculate the slope. What is a slope? Slope is denoted by the letter m and slope is defined as the change in y-axis to the change in x-axis. As you can see here, I have got a right angle triangle ABC. Here this forms a right angle triangle ABC, and using this right angle triangle ABC, I am going to write what is the change in y-axis and the change in x-axis. Slope is the ratio of change in y-axis and by the change in x-axis. So, I can write this as equal to the change in y-axis is nothing but BC. The change in y-axis is BC divided by what is the change in x-axis? It is AC. The change in y-axis, this is what the change in y-axis, which is nothing but BC, and the change in x-axis is this, and that is nothing but AC. So, I have written change in y-axis as BC and change in x-axis as AC. So, what is BC and AC? You can see BC is the change in position. So, this is x2. This complete thing is x2, this is x1. So, what will be this? It is x2 minus x1. So, BC is x2 minus x1 divided by change in x-axis, that is AC, is nothing but T2 minus T1. Let us write this as T2 minus T1. Next, I can also write this as delta x by delta t. So, delta denotes that small change in x-axis to the change in y-axis. So, whenever we write change, we are going to use this delta. So, delta x by delta t is nothing but the change in the position to the change in time. And what is BC by AC? If this forms a right angled triangle and this is angle theta, this is the 90 degree, then this side BC is nothing but the opposite side. This becomes the opposite side and AC is the adjacent side. So, I can also write this BC by AC as opposite by adjacent. Then opposite by adjacent is nothing but tan theta. It is nothing but tan theta. So, you can write slope as denoted by the letter M, which is equal to tan theta. Next, whatever the slope we have found here is the change in the position to change in time. That means this is nothing but the velocity. As we all know, velocity is displacement by time. Change in position is nothing but displacement. Displacement by time gives us the velocity, and this velocity is nothing but the average velocity, delta x by delta t. So, from this we have learned that the slope of this position time graph is velocity. Very important. Remember this, the slope of a position time graph is velocity. Slope of xt graph, nothing but position time graph, is velocity. Now we know what is the average velocity. Using this graphical interpretation, we have learned about the average velocity. Next, let us see what is instantaneous velocity, or how we are going to find the instantaneous velocity. What is instantaneous velocity? It is the velocity of the body at any instant of time. So, if I have to find the instantaneous velocity of a body at point A, what I am going to do is, I will bring this point B closer to A. Let us bring the point B closer to A. Now, when I bring the point B close to A, so let me bring it here and check. This again forms a right angle triangle and there is no change in this angle theta. Let me bring this point somewhere here. Again the angle theta is not changing, it is the same. So, let me bring it here. Again the angle is the same. Next, I am going to bring it very close to A. Even then, there is no change in this angle. That means, if you bring point B close to A, you are bringing point B very much close to A, so that you can find out what is the instantaneous velocity at the point A. That means you are bringing this delta t very much near to 0. That means delta t is brought very much near to the value 0. Delta t never becomes 0. Delta t is tending to 0. That means delta t is approaching a value which is near to 0. It is not becoming 0. So, when I am going to make this delta t approach the value which is very much near to 0, that is, I am bringing this point B very much near to A. But there is no change in tan theta. So, we have to find what is tan theta, but there is no change in tan theta. If there is no change in tan theta, we had already written V average is nothing but tan theta. So, if tan theta is same at all the points, there is no point in finding out the instantaneous velocity, because in a uniform motion, the average velocity will be equal to the instantaneous velocity. So, in case of uniform motion, average velocity and instantaneous velocity will be the same. And you should remember one more thing, it is a straight line, and in case of a straight line, wherever you are going to find the slope, in whichever point, you can consider a point here and here or somewhere here, anywhere, in case of a straight line, the slope will be constant. So, in a straight line, If the graph is a straight line, then slope is constant. Therefore, here the average velocity and instantaneous velocity will be the same. There is no change in them. So, next case I am going to take a non-uniform motion. Case 2 is for a non-uniform motion. So, what is non-uniform motion? When a body travels unequal distance in equal intervals of time, that motion is said to be a non-uniform motion. Since this is a non-uniform motion, a position time graph will be a curve. In case of a uniform motion, it was a straight line. But since this is non-uniform, this becomes a curve. Now, let me consider 2 points here. First point A and this one is B. I am going to join these 2 points. So, if I draw a corresponding vertical line, this is T1 and this becomes T2. I need to join these 2 points A and B. Therefore, I am going to join them using a chord. So, I have drawn a chord to join them. I have extended this chord to the x. I have made an intercept with the x-axis and I am going to call this angle as theta. Here, I will draw a perpendicular which forms a right angle triangle and this angle becomes theta. They are corresponding angles. So, this forms a right angle triangle and we all know the average velocity is equal to this BC. So, if this is C, BC by AC, the change in y-axis to the change in x-axis, and this is equal to delta x by delta t. As in the previous case, we are going to consider the average velocity as the change in position by the change in time, delta x by delta t. Next, to find the instantaneous velocity, how do I find this? Instantaneous velocity. So, in a session 2, we had just defined the instantaneous velocity. Now, using this graphical interpretation, I am going to write a formula for this instantaneous velocity. For that, let me say I need to find out the instantaneous velocity at the point A. So, this is where I have to find the instantaneous velocity. Let us bring the point B very much near to point A. Since I have to find the instantaneous velocity at point A, I will bring this point B very much near to A. That is, the change in the time is going to become very small. As this approaches 0, B will come very much closer to A. The idea is I need to bring this delta t very much near to 0. Whenever I write delta t with this symbol, that means delta t is approaching 0, approaching the value of 0. That doesn't mean delta t becomes 0. Delta t will never become 0, but it is coming very much near to the value of 0, so that this point B comes very much near to point A. We'll write B lies very close to A. Now, what happens if I bring this point B very much close to A? So, let me consider the point somewhere here. So, this is where B is. I am just shifting the B towards A. So, if this becomes B, then the chord changes. So, if the chord changes, you can see this angle theta will change. Next, again I am going to bring this B somewhere here. If B is brought even more closer to A, then again the chord changes. So, if chord changes, this angle theta is going to change. So, at every point the angle theta is changing. But in our previous case, that is for a uniform motion, the theta remained the same throughout. Here, as our B is approaching A, the angle theta is changing. Therefore, here the average velocity is not equal to instantaneous velocity. The velocity at each point will be different. But in the previous case, the uniform motion, the instantaneous velocity was same at all the points. But here it is different. Now let me bring the point B on A. So I have brought B on A. Next, what I have to do? I am going to draw a tangent to this point. You know, tangent is a line which touches this point A. So where do I draw a tangent? Tangent is drawn on the curve for that point where I have to find the instantaneous velocity. So since I have to find the instantaneous velocity at this point A, I am drawing a tangent to this point A. So I got this tangent A. Now let me extend this tangent A. Then this angle, let me name it as alpha. So this alpha is different from this theta. Now what is the instantaneous velocity? V instantaneous is nothing but tan alpha. So tan alpha gives me the instantaneous velocity. I can also write instantaneous velocity as equal to limit delta t tends to 0, then delta x by delta t becomes equal to dx by dt. So this is the instantaneous velocity. What does this limit delta t tending to 0 means? Delta t is approaching the value of 0. That means it is the point B is coming very much near to A. As delta t tends to 0, this delta x by delta t is the change in y-axis by change in x-axis becomes equal to dx by dt. This is the way you are going to define a derivative. So here you can see we have replaced delta by d. Delta is replaced by d. That means d denotes a very small change in y-axis to the very small change in x-axis. So wherever I write delta, that just means a change in x-axis to the change in y-axis. But when you replace delta by d, that means it is a very small change in this position axis to the very small change in the time axis. That is, for finding the instantaneous velocity, you are going to write it as dx by dt. I can also write velocity as the first derivative of displacement. Velocity is also called as first derivative of displacement because we write the velocity as dx by dt. So what does the derivative means? Derivative is, as you all know, the time is an independent variable and x or the displacement is a dependent variable because as time advances, the position of the body is changing. So x is depending on the time. Therefore, derivative means the x or the displacement is changing with respect to time. So this denotes that there is a rate of change of displacement with respect to time. Therefore, we call velocity as the derivative of displacement. So let us revise whatever we have studied about speed and velocity. Speed is distance travelled by time taken, whereas velocity is displacement by time. Speed is a scalar quantity, velocity is a vector quantity, as vector also depends upon the direction in which the body is travelling. And in case of uniform motion, the body travels equal distance in equal intervals of time, or it is going to complete equal displacement in equal intervals of time. But if it is not a uniform motion, then it becomes a non-uniform motion. Then we have to calculate the average speed or average velocity. So what is average speed? Whenever the speed is not uniform, the speed is varying, we are going to calculate the average speed. So average speed is given by the formula total distance travelled by the total time taken, and average velocity is the total displacement by total time. Now I also can find the instantaneous speed and instantaneous velocity of a body. If a body is travelling with certain velocity and that velocity is a variable velocity, then I need to find the instantaneous velocity. And we have the formula for average velocity. V average is equal to the change in the position of the body by the time, which is equal to delta x by delta t. And the instantaneous velocity is the velocity of the body at any instant of time. So whenever the body is travelling with variable velocity, I can find out the instantaneous velocity of the body. So this instantaneous velocity is equal to the delta x by delta t when the limit delta t tends to 0. You learn about this limits in your mathematics in the chapter limits and continuity in detail. So this is about the instantaneous velocity, and this can also be written as dx by dt. So velocity is said to be the first derivative of displacement. One example of instantaneous speed is the speedometer in your vehicles. The speedometer gives us the instantaneous speed of the vehicle. So, and there is one more meter called odometer, which gives us the total distance travelled by the vehicle. So this is the position time graph. In this position time graph, we already have discussed that the slope of this position time graph is nothing but velocity. Remember this. If you are going to find the slope for the position time graph, that is the change in y-axis to the change in x-axis, we are going to get velocity. Now let us discuss all these four graphs. So coming to the first one, so you can see I have plotted position in the y-axis and time in the x-axis, and this is what the straight line we have getting. So what does that mean? What will be the slope of this straight line? This line is parallel to the x-axis or the time axis. Whenever it is parallel to the time axis, whenever you get a straight line which is parallel to the x-axis, you say the slope is 0. Because slope is change in y-axis to change in x-axis. There is no y-axis. So there is no change in y-axis. Therefore, the slope here is 0. If the slope is 0, that means velocity is 0. If velocity is 0, I can say that is there is no displacement, or we can say the body is at rest. The body is at rest. That means even after the time advances, the position of the body is same. You can see the position somewhere, let me take this as x0. The body is somewhere at x0 throughout. Even if the time is changing, this position is not changing. That means the body is at rest. Second case. In this second case, you can see we have got a straight line, and you can just look at it and tell me that this is a uniform motion. So if we are going to get a straight line, it's a uniform motion, and here the slope is constant, because for a straight line the slope will be constant. Slope is constant in the sense it is velocity is constant. The velocity is not going to change in this case. So if velocity is kept constant, then this becomes a uniform motion. Since velocity is constant, this is a uniform motion, and slope will be the same at each point. Wherever you are going to find the slope in the straight line, it will be the same. as t increases, x is also increasing proportionally. So, x and t are proportional to each other in this case. So, it is a uniform motion. It is a uniform motion. And here the slope is positive. You should also mention this. Slope is positive. Coming to this third case, you can see there is decrease here. So, as x-axis increases, y-axis is decreasing. Therefore, I call here the slope as negative. So, in this case, there was increase. As x increases, y also was increasing. Therefore, the slope is positive. But since as x increases, y is decreasing, the slope should be taken as negative. And it is a straight line, therefore, there will be a constant slope. Therefore, the slope is constant and it is negative. Next, coming to the fourth case, you can see here it is not a straight line. We have got a curve, some curve. That means the slope in this case is going to vary completely. So, if you find the slope at this point or this point, it will be changing. Slope is changing. What do you mean by slope changing? That means velocity is changing. If velocity changes, then this is a non-uniform motion. If the velocity is changing, we can say that the body is accelerating. So, the next concept which we are going to study is acceleration. So, in today's class, we have studied about the graphical interpretation of average velocity and instantaneous velocity, and also we learnt about the position time graph. These four cases are very important. These will be asked for 2 marks in your examination. So, this is where I am going to end the session. In the next session, we are going to solve some numericals on speed and velocity, and let us start the new concept, acceleration. Thank you.